Welcome and thank you for joining. We'll continue with the lesson on limits, and more specifically, we are exploring one-sided limits. Recall that one-sided limits describe the trend in the y values, or the estimated y values of a function, as x approaches a specific value from either the left or right side of it. So by one-sided limit, we mean either the limit of f of x as x approaches a number a from the left side of it, or the limit of f of x as x approaches a from the right side of it. So our first examples were about finding the one-sided limits in rational functions and piecewise functions, which are basically graphical representations of one-sided limits. So for example, when you want to find out the limit at x equals 2, you approach number 2 from the left side of it, or number 2 from the right side of it, and you determine what the limit is. As x approaches 2 from the left side of it, the values of y are going towards negative infinity. From the right side of it, the values of y are going towards positive infinity. As you can see, this explanation is quite graphical, so you need to draw the graph of the function in order to see what the limit becomes. Similarly, we looked at the limits, one-sided limits in piecewise functions. Now, this time, we will explore how to find determine the one-sided limits algebraically. Recall that again, that one-sided numbers do not have a specific value. So for example, when we say x is approaching number 2 from the left side of it, so let's draw the number line in here one more time. Here is number 2, here is the left side of number 2, and here is the right side of number 2. So as x is approaching number 2 from the left side of it, it means that number 2, we are getting very, very close to 2, so 1.9, 1.999, 1.99999, so we can continue on forever writing 9, so which means that number 2 from the left is not a definite number. And similarly, we're going to say that number 2 from the right is not a definite number, so we just know that is a number. So this is like a symbol that we use to indicate that this number is very, very close to number 2, but we don't know a specific value of it. So when this happens, then in mathematics we say, well, this is not a definite number. This is an indefinite number or undefined number. Now, remember that whenever we deal with undefined numbers, we're able to estimate some of the expressions that contain indefinite numbers, but not all of them. So before we before we go over examples of how to find the limit by factoring, we're going to go over how to operate with one-sided numbers. Now, the most common one-sided number that we encounter in finding limits, at least in this course, is 0 plus and 0 minus, and we're going to call them the one-sided zeros. So let's talk about one-sided zeros and see how they mingle with other numbers in an expression. So first question is, can we divide a number by a one-sided zeros? For example, can we divide a positive number by 0 plus? So imagine you have a positive number, let's say positive 2, and you are dividing it by 0.0000, and you can continue on forever. So we obtain a very large number in this case, and the smaller this 0 becomes, or the closer 0 plus gets to 0, then the larger the value of the entire fraction becomes. So we're going to say that the answer in this case will be infinity. So the answer is, yes, we can divide a positive number by 0 plus and we get infinity. A positive number by 0 minus will give negative infinity. So again, try to imagine some positive number, number 4, divided by negative 0.0000, and you can continue adding as many zeros as you wish, never ending. So you're going to get a very large negative number. A negative number divided by 0 plus, remember 0 plus is a positive number because 0 is neutral. So if you are on the right side of it, you are in the positives. So negative over 0 plus, that would be equal to negative infinity, and a negative number by 0 minus will be positive infinity because it's negative over a negative positive. Now, therefore, we're going to say, yes, we can divide a number by a one-sided zero, a constant number. Now, Different than 0 always. So we got to mention that. Now, can we divide one-sided zeros by a constant number? So if you have a 0, divide by a positive number, then we still get 0. Well, 0 plus. 0 minus over a positive number, so we still get 0 minus. So remember that this can be indefinitely close to 0. Okay? And then 0 plus over a negative number, that's another 0 minus. 0 minus over a negative number, that would be a 0 plus. Now, the next question is, can one-sided zeros divide each other? So, if you have 0 plus divided by 0 plus, that means that we have 0.0000 indefinitely close to 0, right? Over 0. And this 0 here may be this much close, for example, right? So these are two different 0 pluses. You don't know how close each of them is because these are, again, indefinite numbers. So if you divided this, you would get, quite a small number. And if they switch places, you get quite a big number, which means that because the sizes of each of them are indefinite, then we cannot divide 0 plus by 0 plus. So therefore, we're going to say this is not possible. It doesn't exist. The same thing can be said about 0 minus and 0 plus. So we're going to say it doesn't exist. And then the same thing in here, it doesn't exist. So what that means is that whenever we are evaluating or estimating limits, one-sided limits, that end up being this expression, it means that this is undefined and we need to search for better ways to estimate that limit. So next, can one-sided zeros multiply with infinity? So if anything multiplies by something close to 0, even infinity, it will become 0. So we're going to say positive number with 0 plus is 0. Positive number with 0 minus is going to be 0. Well, that's 0 minus, and that's 0 plus to be more specific. This will be a 0 minus because of the negative and a positive. And two negatives will give a 0 plus. So, two 0 pluses will give a 0 plus. A 0 plus with a 0 minus will give a 0 minus, and two 0 minuses will give a 0 plus. Now, when you multiply a 0 by infinity, that will give a 0. So 0 and infinity can cooperate with each other. So one-sided 0 with infinity. I think I forgot to mention that in here, but here we go. So if you have 0 plus and infinity, that would be equal to 0. And 0 minus and infinity, that would be equal to 0 as well. Obviously 0 minus, and this one here is a 0 plus, and so on. You get the idea. Now, can we add or subtract one-sided zeros? So let's add one-sided zeros to a number. So if you have any number, add a one-sided zero, that would be very close to the number itself, so that exists. Any number, take away a 0, that would be the number approximately. We're talking about a number in here that is different than 0, but that is different than 0. Now, the last one that we are going to talk about is 0 plus plus 0 plus. So 0 plus and 0 plus, you add two very small numbers, you get one very small number. It's a positive. You add two negative zeros, then you're going to get a very small negative 0. But when it comes to adding, to subtracting zeros, so for example, 0 plus minus a 0 minus, or even 0 plus minus 0 plus, right? Or 0 minus minus 0 minus. Okay, so all these operations are impossible to estimate. So 0 plus minus 0 plus, and 0 minus minus 0 minus. So we cannot find the difference between two one-sided zeros. So we're going to say it doesn't exist. So two are the cases, and it's very similar to what happens with operations with infinity. So the division of a one-sided number by itself, it's not possible, and the subtraction of two one-sided zeros is not possible. Now, let's take a look at an example. So in this example, we have to algebraically determine this one-sided limit. We have the limit as x approaches 3 from the left of 5 over x minus 3. So the first thing I like to do is use direct substitution to see if I can estimate the value of this limit. So as we've mentioned in class, we want to do direct substitution or try direct substitution first because A, that would be that can be probably the only way to estimate, or an easy way to estimate the limit. So we'll be able to estimate it, and we'll be done right away, like following a very simple process. And B, if we see that we stumble upon some numbers that cannot simplify, then we'll understand at least where the problem is, and then find the right approach to solve that problem. So here, instead of x, I'm going to write 3 minus and then subtract 3. So 5 over. Now, it takes a little bit of imagination to perform this very, tricky subtractions in here. So remember, the way that I like to do it is by choosing a number very close to 3 on the left side of it. So try to imagine in here the number 2.999. It's very easy to be confused by that minus that is on top of 3 in the exponent spot. It's not an exponent, and we know it. But that doesn't mean, just because you have a minus here, doesn't mean that the number is negative. So it's still positive, it's 2.999. So 2.9999 minus 3, that would be a distance of almost 0, but it will be 0 minus because negative 3 is bigger than 2.999. And 5 divided by 0 minus, it's a constant, a positive constant by 0 minus, that gives negative infinity. So voila, we're done. So that's all we need to do for this example. Now let's continue with the next one. We have the limit as x approaches 7 plus of 5 over x squared minus 14x plus 49. So again, I'm going to try direct substituting, by direct substituting x with 7 plus. So we have 7 plus to the power of 2 minus 14 times 7 plus, and then plus 49. Okay, so I'm feeling very optimistic in here. I don't know about you. Here we go. So we have a 49 here, and it will be 49 plus, because imagine it is 7 point something squared. So this extra will create this extra in here. Now 14 times 7, so that would be equal to minus. So just multiply these two together. So 14 times 7, that's 28, that's a 98. So that would be 98. And a little bit more, and then plus 49. So there is more that I can simplify here. I know I can add a number to a one-sided number, so I'm going to choose to add 49 to this 49 plus. But either one would have worked, but I think that it makes sense, more sense, and for the purpose of, understanding, these are our first examples. So 49 plus 49 is 98, and it will be an extra 98 in here because you have a little bit extra from this 49, and then minus 98 plus. Now, we don't know exactly how close this 98 is to 98, right? Or this one here. So in this case, we cannot perform this subtraction. So this doesn't exist. So we're thinking, that means direct substitution then doesn't work. So now we have to think of how to make this work. So how to estimate this limit. We always solve a problem by analyzing where the problem is, like what made us stop in here. So what made us stop in here was that the fact that we had to subtract two one-sided numbers. The reason why we had two one-sided numbers, remember in the previous example, we didn't have two one-sided numbers. We only had one, so we were able to get away with it and then just finish the evaluation quickly. But here we ended up with two one-sided numbers. And what brought in the two one-sided numbers? Well, the substitution of 7 in two spots, and that's because x was present in two different terms in the denominator. So that makes us think, so if I can only actually change this expression in such a way that I won't have to have these two together in one, in one expression in the denominator. So, and the method actually that can help us estimate this limit would be by factoring. So what we are going to do is we're going to rewrite this limit. This time we are factoring the denominator. The denominator's factored form would be x minus 7 times x minus 7. So at least in each factor I will not have two terms that contain x. And even if I ended up with one-sided numbers in each bracket, in each factor, at least I know that multiplication of two one-sided numbers is possible. It's a division and the subtraction that shouldn't happen. So here we go again. We're going to say we have a 5 in here. In the denominator, we have 7 plus minus 7. And then 7 plus minus 7 again. So that would be equal to 5 over 7 plus minus 7 is 0 plus. And then 0 plus. Two 0 pluses can multiply each other just fine. And we get a 0 plus down here. And 5 divided by 0 plus would be infinity. So the limit as x approaches 7 plus of this particular function would be infinity. If we were to check our answers, and it's always good to check your answers for two reasons. You can check if you're right or wrong. And reason number 2 is you can make connections between your algebraic thinking, which is abstract thinking, and the graph, and then we can see how things work together. So what we had there was 5 divided by x squared minus 14x plus 49. I'm going to enter the equation of the function exactly in the exact form it was given. And as you can see in here, as x approaches 7, so here is 7, you see the flashing vertical asymptote there as I try to change the scale of the graph. So as x approaches 7, the values of y are heading towards infinity. Let's move on to our last example. So this time we have example 7, limit as x approaches 6 from the left of x squared over x squared minus 6x. So this time, again, I will try direct substitution, see if it works. So I have 6 minus to the power of 2 over, down in the denominator, we have 6 minus to the power of 2 minus 6 times 6 minus. So 6 minus to the power of 2 would be 36. So this would be a little bit less than 36 because it's 5.999 squared. So I'll write that down here. Now, in the denominator, again, we have 36. We just discussed that this would be 36 minus, and minus, and now we have 6 times 6 minus is, again, 36. And what you have in here is full number 6 times 5.999. So that would be 36, a little bit less. So what we have in here is some constant number. And down here we have the difference of two numbers. Now we're thinking, how can we deal with this? Because we cannot subtract, right? Two numbers, two one-sided numbers, or two same one-sided numbers, because we don't know what the gap will be, how many zeros will be in between them, right? So how big a gap is in between these two one-sided numbers. So that means that shouldn't be the approach. And obviously we're going to try a different approach in here. So we'll start by the limit as x approaches 6 minus. We'll start by factoring, right? Just like we did in the previous example. So we are going to factor out x from the denominator. And then we have x minus 6. So what we get in here is the limit as x approaches 6 minus here. So we have x over, so obviously we are simplifying this, x minus 6. And here we go again, we have x approaching 6 minus, and here we get 6 minus over 6 minus minus 6. So let's continue on. We are going to simplify the denominator, so 6 minus. And now 6 minus minus 6, so try to imagine this. So that's 5.999 minus positive 6. So that would make a 0 minus. Now remember that 6 minus is one positive number. It's like 5.999. 0 minus is a very small, close to 0 negative number. So we have a positive over a negative, which will create or make a negative. And a fixed positive number divided by 0 minus will give negative infinity, and that would be the limit to this function. So I hope that this made sense, and I hope that you enjoyed more about numbers and the magic of them, because who would have thought that numbers, one-sided numbers, can be so interesting and tricky in the meantime. Well, thank you for learning with me, and bye for now.